Right, happy Monday. It's the Monday the week before spring break. And I can only imagine what this week would have been like if we were actually at school. Probably a lot of you guys would be energetic, super excited for break. But now I think we're even more ready for a break. um, without further ado, though, you have corrected your note sheet. That was item number 1 for today, based on the key, or not the note sheet, the worksheet that you worked on. And there's a piece of that we removed from it because we wanted to really focus in on it because it's a newer idea specific to quadratics, and it's also going to be one of the things that we'll focus on almost entirely after spring break, and that is the x-intercepts of the quadratic function. So an x-intercept, the definition of an x-intercept is a point on a quadratic function's graph, aka the parabola, at which the graph intersects with the x-axis, hence the name x-intercept. And so in this case on Desmos, the points for this example one would be -4, 0 and 2, 0, meaning at that point. And you see how the y value is 0 because when we are on the x-axis, our y value is going to be 0, right? It's not any y values high and it's not any y values below. So the partner, I guess you could say, to the x-intercept would be the y-intercept, which we most commonly know, and that's when it crosses the y-axis. And as you'll see here, when we cross the y-axis, x is 0. So you'll see how it kind of flip-flops. When you cross the y-axis, the x value is 0. When you cross the x-axis, the y value is 0. And that is the way that if you were looking at a table, that's how you would distinguish between the two of them when you don't have a graph to look at. Anywho, so there are 3 scenarios where you might have 2 x-intercepts, you might have 1 single x-intercept, and you might have 0 x-intercepts, all possible with a quadratic because it makes this parabola. It's a U-shape. It goes up to infinity in this direction on the left side, and it dips down to a minimum point, which is your vertex, and then it goes all the way back up to infinity on the right-hand side. And so there is a barrier here where we don't go any lower. And so what if that barrier doesn't make it past the x-axis? Then we wouldn't have any. So for starters, this is our starting example where you have 2 x-intercepts. And the way you figure out where they are on Desmos is you graph them and you can click at the points and they will show up automatically. Now, they aren't always going to be perfectly nice numbers like this, but I designed it that way so it's a little bit easier on our eyes. Now, this is probably the most common situation that you'll have when you are given a quadratic, is you are most commonly going to have 2 x-intercepts. And it's kind of the go-to because we've got one going to the left and one going to the right. It's got that parabola shape, and so it's got the 2 sides to it going up to the right, up to the left, or down to the right and down to the left. And so that is our default. However, if I switch to my second one, here's a situation where there's only 1 x-intercept. If I zoom in here, you'll see that it's getting to the decimals, but you'll see that there is only 1 x-intercept. Let me get back to the norm here. And that is at the point 0, 0, the origin. Now notice this is the parent function. If we look here on the left, this is the parent function of a quadratic because it's the most basic form. There is no bx term and there's no c term. And since those don't exist, since there's no b, it does not cause it to shift to the left or to the right. And since there's no c, it doesn't cause it to go shift up or shift down. So since it's just the x squared, the x-intercept is going to be at 0, 0. And this is what we call the this is what we call the parent function of a quadratic. Now I'll give you guys another example. It's not always going to be this, where there's only 1 x-intercept. Example 3, here's another potential one where it's graphed, and if you look at the equation over here, x squared minus 12x plus 36, you'd look at that and you'd go, well, there's a b and there's a c term. And so it is shifting to, in this case, since the b is negative, it's shifting to the right, and since c is positive, it's going up. Well, that is true. Now, if I were to eliminate the 36, we would have our quadratics that shifted to the right, but it's got 2 x-intercepts. But that's because the vertex is at negative 36. So when I add 36, it brings me back up to this single x-intercept of 6, 0. So here's an example, and this is just giving you proof that this example, x squared, f of x equals x squared, that's not the only situation where you would have one single x-intercept. Now, I can, in this case, for this example, I can make it become negative, right? Make it do a little dance. And it's still going to have one x-intercept, so it doesn't always necessarily matter if I have a negative out front or not. You might have one single x-intercept in either case. Now, last but not least, we might have 0 x-intercepts, where there's none, where it does not cross the x-axis at all. And this is an example right here, x squared plus 3x plus 9. Now, there is an algebraic explanation for this, and we will get to that eventually once we dig a little bit deeper. But the vertex, the minimum point in this case, because this is an upward-facing parabola, it's a happy face, the mood is happy. Since that's the case, there is a minimum point, and that minimum point does not cross the x-axis. It does, however, have a y-intercept, but not an x-intercept. Not 2, not 1, 0. So these are the situations. Now, the Delta assignment that you will be doing today has 5 picked out problems where you're asked to find the x-intercepts or the roots. One thing I'm going to mention to you now, just get used to this. They call the x-intercepts the points that cross your x-axis. They also call them roots. And so those two terms we need to remember and program ourselves to say, when I hear the word roots, I'm really thinking of x-intercepts. We will most commonly use x-intercepts, but I gave a couple in there where they ask for the roots, just to kind of get your head in that headspace, really. So that is what you will be going to do next, with a couple of other review concepts of combining like terms and distributing. And if you need an example or you need to watch a video, Delta provides those, so definitely check those out. And yeah, that's it for this. My videos always end up getting longer than I planned, but this was a beneficial video. I hope that you got the full understanding here. And happy Delta.